All right, let's talk about two of the biggest buzzwords in tech, quantum computing and blockchain, right? You almost never hear those two in the same sentence. Well, that's what I thought, until a company called Superquantum got up on stage at iQuHACK 2026 and just blew my mind with a vision that connects them in this really, really fascinating way. So let's break down what they're building.
Okay, so on one hand, you've got quantum computing. It's this whole new frontier of computation, right? Promising to solve problems that are literally impossible for the computers we have today. And then, over here, you've got blockchain, the tech behind decentralized, super secure digital ledgers. You know, the thing that powers cryptocurrencies. They honestly seem like they come from completely different universes. So you gotta ask, right? Why on earth would you try to mash these two things together? Is this some kind of perfect match we've all been missing? Or is it just a crazy idea to grab headlines? Well, Superquantum is betting it's the perfect match, and the reason why is, honestly, surprisingly clever. And their whole answer, the core of their vision, is this project they call Qubitcoin. Now, what's Qubitcoin? It's this really ambitious plan to create a totally new kind of incentive. But here's the kicker. It's not about building faster computers. It's about writing smarter quantum software. So let's get into it. What exactly is Qubitcoin? Well, at its core, it's a blockchain, and it's heavily inspired by Bitcoin. But, and this is the crucial twist, instead of miners all over the world burning massive amounts of electricity just to solve random math puzzles, these miners would be competing to solve useful, verifiable quantum simulations. A huge difference. And this whole idea, it's really a clever parallel to the history of Bitcoin mining. Remember how that started? First, people used their regular computer CPUs, then they moved to powerful GPUs, and finally to those super specialized ASIC chips. It was all a race, an incentive for better hardware. Qubitcoin takes that exact same incentive model, but flips it. Instead of hardware, it's designed to spark a global race to build better quantum software. The smarter your code, the better your quantum simulator, the more efficiently you can mine. It's brilliant. And the ultimate goal here, it's huge. The idea is to bust quantum software development wide open, get it out of the exclusive labs of big tech and academia. They want to create this decentralized global community where anyone can compete to push the field forward. You know, tapping into talent from everywhere. But to make a vision like that a reality, they first had to solve one really, really expensive problem. And this is where we get into the nitty-gritty. The core technical challenge is something called the T-gate bottleneck. And trust me, this one little thing is what makes running useful quantum simulations so incredibly, prohibitively costly. So what is it exactly that makes a powerful, fault-tolerant quantum computer so insanely resource-intensive to build and run? Well, the answer really lies in the fundamental building blocks of the quantum circuits themselves. Okay, I want you to think of it like a tale of two different kinds of quantum gates. On one side, you have your Clifford gates. These are the workhorses. They're fast, they're efficient, they're computationally cheap to run. The problem? They're not powerful enough on their own to do everything you want. For that, for universal quantum computation, you need the gates on the other side, the T gates. These are the superstars. They're incredibly powerful, but they are computationally very, very expensive. And this is the heart of the whole problem. The T-count, that's literally just the number of these expensive T-gates you have in your circuit, is the single biggest thing driving up the cost. It's the bottleneck. So if you want to make quantum computing practical, you have one main mission. Get that T-count as low as you possibly can. Okay, so how do you do that? How do you lower the T-count? Well, you might think the answer is to just build better, more powerful hardware, but it's not. The most effective solution, it turns out, is all about writing smarter software. Specifically a process called quantum compilation. So what is quantum compilation? Think of it like a translator and an optimizer all rolled into one. It takes your big abstract quantum algorithm and turns it into the specific step-by-step instructions a quantum computer can actually run. But here's the magic part. A good compiler doesn't just translate. It looks for clever ways to rewrite the instructions, to find a more efficient path to get the exact same result, but with the lowest possible cost. And what's the biggest cost? You guessed it, fewer T-gates.
And this isn't just theory. At the iQuHACK workshop, an expert named Dr. Yudong Cao actually showed everyone how this works. Using some pretty advanced mathematical techniques, we're talking phase polynomials and Reed-Muller decoding, the compiler actively searches for a better, more efficient route to get the same answer. And that route, as you can see, is one that needs way fewer of those pricey T-gates.
Let's look at a real example they used in the workshop to make this concrete. Okay, so they start with a pretty simple 4-qubit circuit. Before they do any optimization, just the basic translation, running this thing required 9 of those expensive T-gates. Okay, remember that number, 9.
And then they run it through their smart compiler. The result? The exact same computation, the same answer, but now it only needs 6 T-gates. That's a 33% reduction, a 1/3 cut in the single biggest cost factor. And it was done entirely with a software fix. No new hardware, just smarter code. This right here is the aha moment. This is what makes that whole Qubitcoin idea suddenly seem not just possible, but really powerful.
And you know, this approach really clicked with people. One of the attendees at the workshop called it a solid introduction to quantum computing and even said it was one of my favorite lectures. And that just goes to show, this software-first way of thinking isn't just powerful, it's something people can really grasp and get excited about.
Okay, so let's tie this all back together. We've been deep in the technical weeds with T-gates and compilers. How does this connect back to that big, grand vision of a quantum blockchain we started with?
Well, it's actually pretty simple. Efficiency is everything. If you can use this advanced compilation to slash the cost of running quantum simulations, that means the act of mining on the Qubitcoin network becomes way more efficient. And that efficiency is the secret sauce. It's what turns this from just a cool idea into something that could actually be a viable working network for quantum innovation.
So let's just trace that whole journey one more time. It all started with the big vision, create Qubitcoin to incentivize amazing quantum software. But there was a huge problem. Those T-gates made everything way too expensive. The solution? Use smart quantum compilation to slash the T-count. And the payoff? A path to an efficient, decentralized network for building the quantum future. It's a really elegant arc. And that leaves us with a pretty fascinating question to chew on, doesn't it? For years, the whole story in quantum computing has been this race for bigger and better hardware, more qubits, better chips. But maybe, just maybe, the next truly revolutionary leap, the thing that really unlocks all this potential, won't come from a new piece of hardware at all, but from a smarter line of code. Makes you think, right?